Hi everyone, I'm a senior Java developer and this is the Java interview series. You're in the first video. In this video, I will help you to face all the basic and beginner level Java interview questions during your programming interview. Here are some questions I mentioned, but it's just not limited to these questions. First, we will understand what is Java compiler and just-in-time compiler, and how the class is being loaded into the JVM and how they run in JVM. What does the bytecode means? And we will also check what are the different memory allocation in Java and how do we manage them, or do we really manage them? So at the end of the video you will be able to answer all these questions and you never have to look back about these topics again. So let's get started. When we write a Java program in .java file, then we compile this source code and compiler generates a .class file. This .class file contains nothing but bytecode. Bytecode is some kind of an encrypted format which is only understandable by JVM. JVM could be of any operating system. This gives Java write once and run anywhere functionality. Because the .class file does not run on any operating system but the JVM. So the same .class file can be run across different operating system and it will give the same result. If you have developed any Java program, then you might have seen .class file. But just let me show you one more time. So this is our .java file, our source code. Let me compile it and show you the .class file. So as you see, this .class file contains a random text which is not understandable by humans, which is encrypted. And if you change anything on this bytecode, it will not run on the JVM. Now after we generate the .class file, what happened next? This .class file will be loaded into memory by ClassLoader. And what exactly a ClassLoader is and what does they do? The job of the ClassLoader is to bring your .class file into JVM memory so that it can run. ClassLoader are of three types: Bootstrap ClassLoader, Extension ClassLoader, and System ClassLoader. Bootstrap ClassLoader is a machine code which kick-starts when JVM calls it. Its job is to load the first Java class loader. This loads the classes from rd.jar. Whereas Extension ClassLoader loads the core Java classes from JDK extension library, basically from ext folder. I'll show you that in a minute. Now System ClassLoader loads the classes found in the environment variable class path. Let me show you the location from where the class loader loads the file. Let's go to JDK location. Inside that, go to JRE folder, then lib folder. Inside lib, you see the rd.jar. This is the first class loaded by the Bootstrap loader. Now on the same location, you will see a folder or directory saying ext. So here it is. Now these are the classes will be loaded by the extension class loaders. Now let's find out the class path location. Go to command prompt, then type echo %classpath%. Now enter. This is the location of your class path. You can check what are all the jars are present there. So from these jars, .class file will be loaded into the memory. Now after loading the .class file into memory, then what happened in memory? So for that, we need to understand a little bit about memory. Memory in JVM is divided into 5 parts. First 3 are class area, heap, and stack, which basically deals with Java. Now other 2 memory are PC register and native methods, which are used to communicate or connect with machine code. But we will only focus on 3 memories: class area, heap, and stack, because it deals only with Java. So first memory is class area, which basically stores the class level data of every class, like constant, fields, and method data. Now second, heap. All runtime classes are loaded into the heap space. Java heap space is used throughout the application lifecycle, and heap contains all the objects which are created. Now, the stack is the third memory type and is a temporary memory where the variables and values are stored when the methods are invoked. So a stack is only used for currently running methods. A stack contains only the reference of the object which are in heap memory. So memory allocation in heap is accessed through a complex young generation and old generation system. But in a stack, it is accessed through a last in and first out memory allocation system. We will talk about young generation and old generation system in a bit. So once the objects are created and variables are given memory, then how does memory is managed in Java after that? In Java, JVM is responsible for memory management. So to be more specific, it is garbage collector. So garbage collection is a process of looking at the heap memory and identifying which objects are in use and which are not, and deleting the unused object or non-reference object. Non-reference object means like that object is present in the heap memory, but there is no reference for that object to be used anywhere. So that object will also be eligible for garbage collection. Now let's take a look at the young generation and old generation system which is used for accessing heap memory. Now what is young generation? Young generation is where all the new objects are allocated and aged. When young generation fills up, this causes a minor garbage collection. A young generation full of dead object is collected very quickly, and some survived objects are aged and eventually moved to old generation. To put it straight, when the object is created in heap, it will be in young generation. The longer it is needed, then it will be identified that it will be needed for a longer period of time, then object will move into a older generation, because old generation contain or store long surviving objects. Alright, so the garbage collection which happens in young generation is called as minor garbage collection, but in older generation it will be called as a major garbage collection. That's it, we need to know about that. But as a bonus, I'll tell you there is one permanent generation. This permanent generation contains metadata required for JVM to describe classes method used in the application, and this will be populated by the JVM at runtime based on the classes in use by the application. And a permanent generation, or sometime called as permgen, has been replaced with metadata since Java 8. So perm size and max perm size parameter will be ignored now. Keep that in mind. Let's move on. So what is the meaning of a term stop the world? Means when garbage collector thread is running and other threads are stopped, meaning the application is stopped for a moment. For example, if you are sanitizing your whole house, then you are not allowed until the sanitization is done. So this sometimes cause unwanted freeze. That's why the garbage tuning and JVM optimization is required to avoid these freezes. And that's why we are learning these concepts. You get it now. We talked about the garbage collection, but when does an object become eligible for garbage collection, right? An object becomes eligible for garbage collection if it is not reachable from any live threads or any static reference. The most straightforward case of an object becoming eligible for garbage collection is if all its references are null. Cyclic dependencies without any live external reference are also eligible for garbage collection. Suppose three objects are referenced to one another but not referenced by any live thread are also eligible for garbage collection. This is sometimes called as cyclic dependencies. So finally, after the JVM loads the .class file at runtime and transform the Java source code into binary code or machine code, and this machine code is used by the interpreter. So interpretation of Java bytecode reduce the performance of native application. It is the reason to implement the just-in-time compiler. Just-in-time compiler accelerates the performance of the application by compiling the bytecode into a native machine code. Now it is a native machine code which is quickly understandable by machine, hence increases the performance. Any programming language, it requires that converting that code into machine understandable form because machine only understand the binary language. Now that we have covered all the concepts, let me show you a practical example so that you will always remember these concepts. Let's go to IntelliJ. Here, let me create a file called main.java. Inside this, I'm going to create a main method, and inside the main method, I'm writing a never-ending while loop and also printing the value of I counter and incrementing it afterwards. So good, now our code is ready to run. Before running this code, we need to open JConsole, and it comes with JDK for all operating system. You can go to JDK location, and inside JDK, the bin folder, open the JConsole and double click on it. Now our monitoring tool is ready. Let's go back to IntelliJ and run the code. Perfect. Now our code is running. Let me open this class in JConsole. Okay, reconnect it. Select the main process. Click on connect. Awesome. We can see all the utilization by our class. Perfect. Heap memory usage, number of live threads, currently loaded classes, and CPU usage. Let's see these things in details one by one. Click on memory tab. As you can see here, the 50 to 80 MB is in usage now. The garbage collection or GC time on Heap is determined by young and old generation. So here only the young generation GC time happened, because only the young generation garbage collection happened. Let's go to threads. Click on main thread. Here you can see all the details of the thread. Let's move to classes. As of now, around 2000 classes has been loaded. So let's move to VM summary. Here we can see all the details like number of daemon threads and total number of threads and which one is your GIT compiler and some other useful information. Finally, let's go to mbeans. Here I'm going to show you only one specific interface class. So as you see, the young generation count is 26, but for the older generation it is 0 because there is no garbage collection happened for the long-lived object yet, and also no notification. Now let's go back to the memory information. Here we can see the memory size is hanging between 30 to 70 MB, more or less. Now I'm going to give a hint to the garbage collector that please perform a garbage collection once you feel right. So click on this perform GC garbage collection. Now you can see the memory came down to less than 10 MB. Now if you check the collection count for the old generation, it should have some number. Let's go and check it. So old generation count is 1 now and young generation count is 183. So to see all this in an overview tab, you can see here. So all the details is present in this overview tab. So that's it for today. Please subscribe to my channel. In next lecture we will cover all the string concepts. See you there. Till then, bye. Take care.